Hi, this is Mr. Gamboa. I'm going to go over the practice exam B, the one that is on Schoology, man. Let's go over it. So we have a German household selected at random. Let big X be the random variable that lets you know the number of cars that this German household owns. Part A, complete the missing probability to complete the probability distribution for big X. So a reminder, when we see this phrase, probability distribution for, and then typically a big X or a big Y, we're talking about this table. So quite simply, these probabilities need to add up to 1. So with the help of a calculator or with some mental math, this is 2 cents and 1 cent, that's 3 cents, 3 cents, and 5 cents is 8 cents, 8 cents and 8 cents is 16 cents, and 16 cents and 15 cents turns out to be 31 cents. Therefore, there needs to be 0.69 cents left to complete 100. Okay, so the probabilities always add up to 1. Next, so the 0.69 needs to go there. What is the expected number of cars in a randomly selected German household? Show your work. Okay, so this is just expected value. To calculate that, we would multiply 0 times 0.69 plus 1 times 0.15 plus 2 times 0.08 plus 3 times 0.05 plus 4 times 0.02 and plus 5.01. Okay, so I do want you to show your work on your exam, and then after that, it's okay to just say I use a calculator from that point. So when you do take a moment, because you're doing this at home, to figure this out, and you would do that on the Desmos calculator, you have a chance to do that, you should find that the number is 0.59. Next part. The variance for big X is 1.1419. What's the standard deviation for big X? Show your work and round your answer to the nearest hundredth. So if we know the variance is this number, remember the idea is the SD for a random variable big X is the square root of the variance for big X. So we simply put that into the calculator. What is the square root of 1.1419? And I think when you put that into a calculator, do that yourself and check with what I'm about to say, I think you're supposed to get about 1.07. That's after you round to the nearest hundredth, so that's 2 decimal places, okay? D, which of the following interpretations best describes the standard deviation of X? Let's read them. And choose one and only one. So this question is multiple choice. The average number of cars is exactly 1.07. Is that what the standard deviation means? The number of cars would typically be about 1.07 from the mean of 0.59. That sounds pretty good. The number of cars would be 1.07 from the mean of 0.59 about 68% of the time. Okay, so that's getting more specific. And last but not least, if many German households were taken randomly, a German household would have an average of 0.59 cars, give or take 1.07. So the good thing that all of these do is they bring up the 1.07, because that's the SD. But the only one that does it very well is D, okay? A runner-up would be option, I would say B. Like this is like runner-up, run-er-up, B. Because it says, it tells us the, like the distance from the mean. That's the mean, 0.59, and it varies by that much. But what's missing is that instance of you saying that you did this picking a random household game, quote unquote, many times, okay? So that's where that part makes it the best interpretation. Moving on, question 2. Because we live in America, we can expect that the average American household owns far more cars than their European counterparts. Let's call the number of cars that American households have big Y. And the relationship between the German households that we just did in the first problem and the American households is given with this relation. Big Y is 2.97 times X. So in other words, American households own about almost 3 times as many cars as their German counterparts. Now let's get to the actual questions on the next page. What's the expected number of cars for American households? Round your answer to the hundredths. So if I remember correctly, 0.59, that's how many cars we expect on average a German household to have. So we just simply multiply that by the 2.97. Okay, and we get whatever that answer is. I don't have the answer off the top of my head, so I'll do the math right now on my phone real quick. And I get 1.7 1.7523, but I want to round that to the nearest hundredth, so just simply put 1.75, okay? Question 2, what's the standard deviation of cars for American households? Well, the standard deviation for the German household, I think it was 1.07, right? So when everything gets multiplied by a number, in this case a 2.97, the mean gets multiplied by 2.97, and therefore the SD also gets multiplied by that same amount, right? Because the SD is a measure of how far you are from the mean, right? It's always the give or take from the mean thing, okay? So we just simply multiply and round appropriately. I'm doing the math right now. 2.97 times 1.07 gives me 3.1779. So round to the nearest hundredth, that's 3.18. Okay, cool. Next part. Suppose Donald Trump issues a Trumpy boy free car day in time for the next political election. In this situation, every American household gets given a voucher to get one free American-made car. Let Big Z be the number of cars in America after everybody has cashed in that free car day voucher. And let's suppose that every household in America cashed in the voucher and has received their car. Question, what's the mean for Big Z? Well, before, the average number of cars America would have was 1.75, but since everything goes up by one more car, we'll simply add one more. So after the Trumpy boy free car day, an American household has on average, right, 2.75 cars. That's a lot of car. What's the new standard deviation? Explain your answer. Well, we should just take the ST from before for the American household, the 3.18, and just recopy it, right? And then we explain to the person, adding, right, the plus 1 does not change the spread. Okay, so if we looked at the data of all the different cars in America, if everyone goes up by one car, then everyone is just as far above or below average as they were before. So the standard deviation remains the same. Remember, standard deviation is the average distance from the mean, okay? So that didn't really change since everyone went up by one. All right, question 3. Suppose you're an American and you have recently married a nice German partner. What is the expected number of total cars your American/German household now owns? Show your work. Okay, well, in this situation, I want to be clear when you're doing this problem, because you might ask yourself, are you talking about America before the Trump free car day or after? And for this one, let's say it is before, because I didn't put here, this is after the free car day. So let's, when we say America, let's do the big Y, right? Because that represented American households. And German households was big X, right? So I'm basically asking us to combine these two together. So what was the mean number of cars we had in America before free car day? I think it was 1.75. And what was the number of cars a German household owned? If I remember, I think it was 0.59. Okay. So on average, we would just add those two things together. Can I do mental math? I don't want to do mental math. It's like the end of the day. 1.75 plus 0.59 ends up being 2.34. Okay. So in this new American/German household, we would expect an average of 2.34 cars. All right. What's the standard deviation for this joint American/German household? Show your work. All right. So for this one, remember when we think about the SD of this new household of big Y plus big X, we don't just add the SD of Y and the SD of X. Instead, we add the variance for big Y and plus the variance for big X. Once we combine the variances, then we do a big square root, as we're used to doing to create a standard deviation. Okay? So to create the variances, if you look back through the work, I don't think we were ever told the variance for both of these. I think we were given the variance for X. But in case you don't want to do that, remember, basically you're doing a square root. We're adding two things. We can go from variance to SD back and forth by just taking the SD and squaring it. So I know the SD for big Y, the American household at the end was 1.07. So I just simply put that there and then I put a little squared on it, okay? That's another expression for the variance of Y, of American households. And then the variance for American households, if I remember what was that? Oh, sorry, big X is German households. The variance on the German households, I want to say, was 3.18. And so we'll square that, okay? And then we'll add them together and then do the big square root. And I think I misspoke. Y is American household, so that's actually the bigger one. And then X is German household, that's the 1.07. But luckily for us, because we're combining these things, because we're adding them, it really won't matter, okay? So to figure out the combined standard deviation, we do the square root of 1.07, make sure that's squared, add that to 3.18, make sure that's squared, and make sure that's all in the square root. And if you did that correctly, according to my calculations, and so if Kylie, you're watching this video, I did use iPhone, so I'm taking a chance here. This is 3.36, okay? Because I think I wanted it rounded to the hundredths again. So your combined SD is 3.36. Okay. All right, next question. Let big V be the difference in how many more cars an American household has than a German household. Question. What's the mean for V? So here they're asking how many more cars on average does the American household have versus the German household? So this is typically just saying, why don't you take big Y and subtract it from big X? Take the American household, that's Y, and the German household, X, because it's smaller, and subtract it. So to find that mean, we'll just subtract those numbers. So if I look back to my work, instead of taking 1.75, that's the average number of American households, we'll subtract that instead of adding it from the typical German household car count. And so these subtract. So if I have $1.75, subtract 0.59, I'm going to do that on a calculator again because it's late and I'm tired. And I get 1.116. Okay, nice and easy. Last but not least, what's the standard deviation for big V? So for this one, again, you should immediately just write down 3.36. And we can say the SD for big Y minus X is the same as the SD for big Y plus X, okay? And that'll be it. As we've gone over, right? Anytime you combine SDs by adding or subtracting, the SD is the same for both. So you only have to do it once. Okay, and then we got the extra credit here. So in this situation, I'm just gonna let you try that on your own. I can help explain it. It says here, Jenny's car is parked at the same garage by her work every time she goes to work. Sometimes her work takes a long time, and other times her work lets her leave home earlier. Because she stays at work for different lengths of time each day, the fee the parking garage charges on a random day is a random variable. In addition, the city charges Jenny $3 every time she uses the garage as a means to collect taxes for the city. So here's the probability distribution for how much Jenny had to pay to leave the garage. And this, again, does not include the $3 fee that she has to pay the city every time she uses the parking garage. So sometimes she pays $10. That's probably on a day where she was at work for not a long time, and that happens 20% of the time. And on the other end, sometimes she's paid $20, maybe because she had a very long day at work. She had to pay, a greater parking fee. Like, pretend maybe this is an hour, this is 2 hours, 4 hours, and maybe that's like 5 hours plus, right? And we have that. So my expectation for y'all on this extra credit, right, if this was the real thing tomorrow's extra credit will be different, but as you guys noticed, the extra credit is always something you can do based off what we've seen. I want you in this situation, calculate the expected value for the total amount of money Jenny has to pay for the parking and for leaving the garage. And then I want you to calculate and interpret the standard deviation. So what I'll say is if you want to figure that out, do the math, right? Like multiply 10 times 0.20, add that to 13 times 0.25, so on and so forth to get your mean. And then you got to do something about the $3 fee, okay? So I'll leave that to you. Figure that out, and then calculate the standard deviation. And that standard deviation is going to be, it's going to be work, okay? Because you're going to have to take whatever you got as the expected value, remember? Subtract it from 10, square it, multiply it times 0.20, add that to 13 minus the expected value, square that answer, multiply it by 0.25, so on and so forth, right? And then you'll do a big square root and you get your SD, and then I want you to write a sentence, okay? So you can expect something similar on your extra credit for tomorrow. I'm just letting you know if you are being a good student and watching this video ahead of time. So if you know how to do this, you should be set up for tomorrow's extra credit. It'll be something very similar. But again, do this on your own. come to me tomorrow, maybe at lunch or before class starts, and then I can let you know if you were right or wrong for this last question, okay? With that said,